All right, this is the video for the third quarter test review for Algebra 2 at Osborne Park High School. We're starting out here. These are going to be multiple choice questions on your test, and the directions for the first part is to simplify these. So we have some rational functions. So for this first one, we know in order to simplify, the first thing I need to do is to factor. So I'm going to start out by factoring x squared minus 9. That is a difference of squares, so it factors into x plus 3 times x minus 3. That's a pattern we should just pretty much have memorized. Next, I need to factor my denominator. So to factor that, I'm going to factor using my area model, where I'll put my x squared and my plus 6, my first and my last terms in, and then I'm going to multiply these two terms together. If I multiply them together, I get 6x squared. So I'm looking for the two things that multiply to 6x squared and add to the middle, which is 5x. So I've got to add to 5x. So I know that both things will need to be positive. I know both things will need to contain an x to give me 6x squared when I multiply and add to 5x. My two numbers would be 2 times 3 would multiply to 6 and add to 5. Now I can take the GCF of my top row, which is x, and then up here, what times x gives me x squared, that's x. What times x gives me plus 3x, that's plus 3. Then down here on the bottom, what times x gives me 2x, that's plus 2, and my check, does plus 2 times plus 3 equal plus 6? Yes, it does. So my factors are x plus 2 and x plus 3. In order for a rational function to reduce, I have to have the same factor on the top and the bottom, and you can see I have an x plus 3 on both the top and the bottom that can reduce out. So my final answer would be x minus 3 over x plus 2. Number 2 is another simplified problem. So on the top, I notice I have a GCF of 5, so I can factor that out into 5x plus y. On the bottom, I just have a 15. If you'd like, you could rewrite the 15 as 5 times 3. That method may help you to realize that I can reduce a 5 out of both the top and the bottom. So my final answer for this one is x plus y over 3. Number 3 is another simplified problem. On the top, I have a GCF of 16x. If I factor that out, on the inside, I would be left with x plus 1. I need to be sure I leave the plus 1 in there. Otherwise, when I distribute the 16 back, I wouldn't have 16x. Okay, so on the bottom, I have a GCF of 2. If I factor that out, I have an x plus 1, and now I'm able to reduce. The x plus 1 factor is easy to see, will reduce, and then also I should recognize that 2 can go into 16 8 times, because 2 is a factor of 16. If I do this, what I'm left with is 8x. On the bottom, I only have a 1, so I don't need to write the denominator because everything's on the top. So that simplifies to just 8x. On number 4, I have a multiplication problem. Multiplication is just to multiply straight across the top and straight across the bottom for a rational function. But I would like to make sure that I can't reduce anything along the way. So I'm going to start out by factoring the top of the first term. That has 5 as a GCF. If I take that out, I have a minus 3 as what's left inside. On the bottom of this fraction, I had a squared. So I can write that as a squared. And then I was multiplying. On the top of the second fraction, I had an a. And on the bottom of the second fraction, I had an a minus 3. Neither one of those are going to be able to be factored. Now when I go to reduce, I notice that I have an a minus 3 on the top and the bottom. It doesn't matter if they're in the same fraction or in the two different fractions, so long as I have one thing from the top and one thing from the bottom. I also have an a on the top of my second fraction that could reduce with one of the a's from my first fraction, so I'd only have an a left over there. So this whole problem reduces. I have my 5 left on the top, my a left on the bottom, and I am finished. All right, number 5 looks complicated, but it's really just a division problem. The top fraction divided by the bottom fraction. These fractions are already factored for you, so I have y minus 3 over y plus 5. I don't know why I didn't put parentheses around the top as well, but I didn't. And rather than write it as dividing by the denominator, when you divide two fractions, you change it to multiplication and you flip the second one. So I'm going to take this second fraction and I'm going to put my y plus 5 on the top now and my y plus 3 on the bottom. I don't want to do any reducing until I've turned this into a multiplication problem. Now that I'm multiplication, it would be everything on the top together, straight across the top, everything on the bottom, straight across the bottom, and I can reduce any factor that's the same on the top and the bottom. So my y plus 5s reduce out. I have a y minus 3 over a y plus 3. Those two are not the same thing, so I can't reduce out anything else, and I'm finished there. All right, number 6 is another multiplication problem. The factors get a little nastier here, but they also ask us to state the restrictions. Remember, the bottom cannot equal 0. So in order to state the restrictions, I want to look at my factored form and make sure none of my denominators equal 0. I'm going to scoot this up some here. Okay, essentially I have 4 factoring problems I need to do before I start here. So I'm going to start with my 3p squared minus 9p minus 30. The first thing I realize with this is that all of my coefficients are divisible by 3, so I'm going to factor a 3 out as the GCF. That will make all of my numbers easier to deal with. Now that I have the 3 out, I can factor what's left inside. It's a quadratic, so I'm going to factor by my area model. I have p squared and I have minus 10. So I'm looking for what two things multiply to minus 10p squared and add to the middle, which is minus 3p. In order to multiply to a negative, I have to have a positive and a negative. They'll both have to have a p to multiply to p squared and add to a negative 3p. So how can I multiply to 10? Well, I could do a 5 and a 3. If they make the 5 negative and the 3, 5 and 2, 5 and 2 will multiply to 10. If I make the 5 negative, then I will add to negative 3p. I start out, take the GCF of the top, so this is also a p. I would need a plus 2 to multiply to 2p. Over here, I would need a minus 5 to multiply to minus 5p. And then my check, does plus 2 times minus 5 equal negative 10? Yes, it does. Don't forget I already took out this GCF, so when I go to factor the top of my first fraction, I have 3 times the quantity p plus 2 and p minus 5. So that's my first problem to factor. Now I need to factor the denominator. So for that one, I had 8p squared minus 56p plus 80. These are big numbers, but again, 8 is my GCF, so I can divide 8 out. 56 divided by 8 is 7, and 80 divided by 8, is 10, not 8. So now I need to factor what's left inside. I can factor again by my area model. So I have to multiply to 10p squared, and I have to add to the middle, which is negative 7p. If I'm going to multiply to a positive and add to a negative, both of my terms will need to be negative. They'll both need to have a p with it. Again, to multiply to 10, I can multiply 5 times 2, and if they're both negative, they'll multiply to a positive 10p squared and add to a negative 7p. GCF of the top row is p, so that's also a p and a minus 5. Over here I have a minus 2, and does, for my check, negative 2 times negative 5 equals 10. So now I factored this denominator. Don't forget the 8 was the GCF that I had out in front, and my two factors were p minus 5 and p minus 2. Now I'm into my second fraction, which is at least a little easier. Factoring the top, I have 4 as a GCF. If I factor that out, it gives me p plus 2. And then my last denominator right here was p squared minus 4. I should recognize that's a difference of squares, so that's going to factor into p plus 2 times p minus 2. Now that I have everyone factored, I could state my restrictions. So my restrictions are where the bottom cannot equal 0. So I would have that p cannot equal 2. From this factor, 5. From this factor, p would not be able to equal 2. From this factor, p would not be able to equal to negative 2. And from this factor, I have 2 again, so I'm not going to write it again. By the way, I skipped the 8 over here and never mentioned why. If I set that factor and say it can't equal 0, I don't have to worry about it because 8 never equals 0. Versus the other ones, when would p minus 5, if that can't equal 0, then p can't equal 5. So I solved each of those to find their roots of the factors in the bottom, and those are my restrictions. Now I'm ready to do some reducing. It's a multiplication problem, so everything from the top can be reduced from anything from the bottom. So what can I reduce out? Well, I have a p plus 2 on the top and a p plus 2 on the bottom that I can reduce out. I have a p minus 5 on the top and a p minus 5 on the bottom. And what else do I have left? Well, as far as my binomial factors, my factors with two terms, I have this p plus 2. I don't have any p plus 2's on the bottom because they're both p minus 2's. So it looks like those parts are done being reduced. Let's look at my coefficients now. Is there anything I can reduce from my coefficients? Well, I have an 8 and a 4, and 4 can go into 8 two times. So I can reduce that. Oops, I'm sorry, I'm writing with a highlighter here, which doesn't work very well. The 3 on the top is not going to go into anything. So my final answer right here, I have a 3 left on the top. I have a p plus 2 left on the top. On the bottom, I have my 2 that was left for my 8. And then I would probably write this as p minus 2 squared. You could also write it as p minus 2 times p minus 2. Okay, moving along to number 7, I've got another division problem. These factors were not your typical quadratic factors, but I can still think of this as having factors with it. I've got 35x to the 4th y over 4c squared. So I could break that down into things that multiply to 35, etc. On the second fraction, since it was division, I'm going to flip it. So I'm going to put my 12c squared on the top and my 5x to the 9th on the bottom. Now I'm going to reduce. Since everything is multiplied, I would have everything multiplied together on the top and everything multiplied together on the bottom. How about the numbers? 35 and 5, I can do some reducing there. 5 goes into 5 one time. 5 goes into 35 7 times. 7's now prime, so I know I don't have to worry about that one anymore. All right, how about the 12 and the 4? 4 goes into 4 one time. 4 goes into 12 3 times. So right now I've reduced out for the number part. I have 7 times 3 on the top, which is 21. And on the bottom, all I have left would be a coefficient of 1, so I don't really need to write that unless I wind up with no variables. Okay, how about x's? I have 4 x's on the top and 9 x's on the bottom. You can think of this as a rule. When you divide two things, you subtract their exponents, which would leave me with x to the 5th on the bottom. You could list them out as 4 x's on top and 9 on bottom. And then the 4 would reduce out, and that can help you see why there's 5 left on the bottom. Okay, what else do I have? I have this y. There's no other y's in the whole problem, so it's going to stay right where it is. Then I have c squared on both the top and the bottom, so that's going to reduce to 1, and my final answer will be 21y over x to the 5th. I doubt they'd leave the 1 there if they were writing this in a multiple choice test. All right, moving on to number 8 is an addition problem. In order to add fractions, I have to have a common denominator. So right now, I don't have a common denominator. I can think of 5 as being a prime number. It's just 5. 10x is really like 2 times 5 times x. So my least common denominator for this fraction needs to be able to build any of the denominators. So I started out, my first fraction was 2x over 5. The least common denominator is going to be 2 times 5 times x, or 10x. That will have all the denominators. So I need to multiply by 2x on the bottom. The only thing I can do is also multiply by 2x on the top, because now I've really just multiplied by 1, which doesn't change something. For my second fraction, I had 3y over 10x. Well, 10x is this 2 times 5x, so I was good there. Now I have the same denominator in both fractions. When I add two fractions, the denominator stays the same. Then I add together the tops. So 2x times 2x for this first fraction is 4x squared. And then I had my plus 3y. X's and y's cannot be put together because they're not like terms. So this is my final answer. Whenever I add, I should always double check if I can factor it some more and reduce, but that doesn't have anything that I can factor, so I'm finished. All right, number 9 is a subtraction problem. I don't like subtraction problems. I'd rather change them to add the opposite so I don't forget about the subtraction. Now it's an addition problem. In order to add two things, I have to have a common denominator. Well, my first fraction was 8 over t minus 4. And my second fraction looked similar, but instead it was 4 minus t. If I want to turn the 4 minus t into a t minus 4, I need to do some sign reversals. The way I do that is by factoring a negative 1 out of the t minus 4. If I divide 4 by -1, it gives me -4. If I divide -1 out of my negative t, it would then become a positive t. So by factoring the negative out in front, I now have t minus 4 for the denominator of my second fraction. So let me scoot this stuff over. All right, now I need to deal with the top. The top was -5. To be truly a common denominator, I can't have a negative if the first fraction didn't have a negative, but notice I have a negative over a negative, so I can just reduce those to positives. So now I have 8 over t minus 4 plus 5 over t minus 4. My common denominator is t minus 4, that stays the same. On the top, 5 plus 8 is 13. So my final answer is 13 over t minus 4. All right, moving on to number 10. Again, I have an addition problem. In this case, my denominator is a little more complicated. I have an x squared plus 2x minus 8. So in order to do that problem, I'm going to need to factor my x squared minus 2x plus 8. It's a quadratic, so I'll factor by area model. I'm looking for what two things multiply to -8x squared and add to the middle that was positive 2x. To multiply to a negative, I need a positive and a negative. They're both going to need x's to multiply to x squared and add to 2x. The way I multiply it to 8 is 4 times 2. If I make the 4 positive and the 2 negative, they'll multiply to -8x squared and add to positive 2x. I take my GCF of the top as x, so that means my top of my second column is also an x, and then I'd have a plus 4 over here in the second column. I'd have a -2 to multiply to -2x, and then my double check, does -2 times positive 4 equal -8? Yes, it does. So my first fraction is going to be written x minus 6 over x plus 4 times x minus 2. This was an addition problem. I'm leaving a little space in case I need to get a common denominator here. My second fraction is 4 over this x squared minus x minus 20. That again needs to be factored. So I have x squared and minus 20. So I'm looking for what two things multiply to minus 20x squared and add to -1x. To multiply to a negative, I need one negative and one positive. To multiply to 20 and add to some version of 1, I can do a 5 and a 4. If I make the 5 negative and the 4 positive, I'll multiply to -20x squared and add to -1x. The GCF of my top row is x, so my first column is also an x. My second column is a -5, and down here on the bottom I have a plus 4. To check, does -5 times 4 equal -20? Yes, it does. And my second denominator is x minus 5 times x plus 4. Right now I'm looking for a common denominator. These two are not the same. Both have an x plus 4, so I know that factor is in common. My first fraction has an x minus 2, so I'm going to need to put an x minus 2 on the top and bottom of my second fraction to get a common denominator for that part. I have to add to the top and the bottom for balance. My second fraction has an x minus 5 that my first fraction was missing. So I'm going to multiply by x minus 5 on the top and bottom of my first fraction. Again, I just multiplied by 1. So as I'm looking at this, don't go through now and start crossing things out. You just did this work to get a common denominator. Don't eliminate it. Okay, I made myself a little more space. Now I need to do some simplifying. When I add two fractions, I add the top and the bottom stays the same. So the bottom's going to be my common denominator of x plus 4 times x minus 2 times x minus 5. On the top, in order to put these two together, I'm going to need to FOIL them out, or I can multiply using my area method, where I have x minus 6 times x minus 5. If I multiply them, I have x squared minus 5x minus 6x and plus 30. Combining like terms, I can write them on the top of my fraction now. I have x squared minus 11x plus 30. These two fractions were added together, but now to finish my addition, I need to put the top of this fraction. I have 4 times x minus 2, so that's just a nice distributing of 4x minus 8. I wish I were done, but I still have to go through and combine like terms. I have two terms with x, and I have two terms without x. So in my last step here, I'm going to rewrite. I have x squared, and then negative 11x plus 4x is negative 7x. Combining positive 30 and negative 8 is positive 22. And that was all over my x plus 4 times my x minus 2 times my x minus 5. Now I'm all ready to go ahead and throw a box around this and call it done. The thing we need to be careful of is that we can't factor the top right here. So I want to double check. Can I factor that? Can I factor x squared minus 7x plus 22? Well, if so, I'm looking, are there two things that multiply to 22x squared that would add to negative 7x? Well, in order to multiply to a positive and add to a negative, both terms would need to be negative. They'd both have to have an x. How can I multiply to 22? I can do 1 times 22, which there's no way I can get 7 out of that, or I can do 2 times 11, which will also not give me 7. So this is prime, it cannot be factored, and I can in fact call the problem done. All right, number 11, 12, and 13 are all problems where I'm supposed to solve. So we'd like to solve these graphically. So the way I did that is I put in y1 in my calculator, I put 3 halves, or 3 divided by 2. In y2 in my calculator, I usually put the left side. Doesn't really matter so much for equations, but it did when we did inequalities. If I'm going to type this into my calculator, I want to type it as 4 divided by 3 plus x divided by 6. I don't technically need parentheses for this one because everything was one term, but some of you guys might put parentheses around them. That would be okay as well. All right, so let me pull up my calculator. So there are my equations in y1 and y2, and I'm going to go to a standard view window to graph this. And I can see, if I think about it, I should realize that the 3 halves should make a horizontal line. And while the other one looks like a rational function, it's not really a rational function because it doesn't have any x's on the bottom. So it's really just a line. So it makes sense that my two lines would only cross once. I can go to GSolve, isect to get the intersection. Remember, the original problem only had x's in it, so all I care about is the x value of my solution, and I'm going to write x equals 1 as the answer for that. All right, moving on to number 12. It is the same type of problem. So when I put this into my calculator, I need to be sure I use some parentheses. I need to put parentheses around each of these factors that were two terms. So I graphed the right side in y1 and I graphed the left side in y2. Let me put my calculator back up there. And I can hit draw. I should realize that, again, these have no x's in the bottom, so they're going to make straight lines. I'm going to go to find my intersection right now. I can't tell very well if they're crossing in my window. It says not found, so I'm going to exit out. Let me go back to my picture here. So I can tell they should be crossing somewhere over here on the right, but maybe my window just wasn't quite big enough to do that. So I'm going to just scoot a little to the right until it looks like I see them crossing. And now when I GSolve and find the intersection, I get x equals 15. Since they're straight lines, it doesn't matter if I keep scooting over more and more, they are never going to cross again. All right, number 13 is another solve problem. So I have this first fraction minus, and now in my second fraction, I need to realize I need some extra parentheses around this denominator here. So I'm going to make this one of my y equals in my calculator. And then on the right, I'm going to have my negative 9/10 that I'm going to put in my other thing in my calculator. So I have typed these into y1 and y2. I can draw them in a standard window. I should recognize that the thing that's boxed in green over here, my first left side of the equation, should make a rational function, something with an asymptote in it. And that's what I see this going on right here. That's this piece. Now, the weird thing about my calculator is it's also showing this vertical line in the middle, but that's not really a line. That's actually an asymptote. So I know no matter what, that shouldn't be included as one of my answers. On the right side, I had negative 9/10, which went right here through the middle. The solutions are the places where my two graphs intersect. It looks to me like my graphs intersect 2 times. I'm going to use my calculator to confirm that. If I go to intersection, it shows them crossing at negative 6.5, which is the solution that's on the left there. If I hit the over button, It also shows they cross at -2. So I need both answers, -6.5 and -2. Oftentimes we write this in curly brackets. And I only care about the x values because my original problem only had x's, so I don't need the y's for this. All right, number 14 is a simplify problem, so I need to do some factoring. I'm going to start out by factoring the top. So I'm looking to factor x squared plus 6x plus 9. I'll factor by my area model. I have x squared and plus 9, so I'm looking for what two things multiply to that 9x squared and add to the middle, which is 6x. To multiply and add to positives, I need both positives. They'll both need to be x's to multiply to x squared and add to 6x. And they also both need to be 3's to multiply to 9 and add to 6. So the GCF of my top row is an x, which means my first column is also an x to get x squared. I need a plus 3 at the top of my second column to get 3x, a plus 3 down here on the bottom to get plus 3x, and then my check, does plus 3 times plus 3 equal 9? Yes, it does. So my first numerator factors into x plus 3 times x plus 3. Now I'm going to factor my first denominator. That was x squared plus 7x plus 12. Again, I'll factor by my area model. I have an x squared and a plus 12. So I'm looking for what two things multiply to 12x squared and add to the middle, my 7x. So they both need to be positive x terms. To multiply to 12 and add to 7, I can do a 3 and a 4. So this would give me x plus 4 and x plus 3. Again, checking that 3 times 4 is really 12, which it is. So that was my first denominator, x plus 3 and x plus 4. Remember that when I'm dividing two fractions, what I'm really doing is multiplying by the reciprocal. So now I'm going to flip this fraction, the second one. I'm going to start out by factoring the bottom there, and I'll write it on the top. Make some more room, and I have 2x squared plus 5x minus 12. Factoring by my area model, I have 2x squared. I have minus 12. So this time what I'm really going to multiply to is the product of both of these guys. So that's negative 24x squared. And I have to add to the middle, which is positive 5x. To multiply to a negative and add to a positive, I need one positive and one negative. How can I multiply to 24? Well, I could do 1 times 24, that's not going to combine to 5. I could do 2 times 12, won't combine to 5. I could do 3 times 8. If one of these is positive and one of them is negative, if I make the 8 positive and the 3 negative, I'll multiply to negative 24 and add to positive 5. So now I go to take the GCF of my top row, which is just x. At the top of my second column, since I have a coefficient here, I'm actually going to need a 2x to multiply to 2x squared. In my second column, I'm going to need a minus 3. Down here on the bottom, remember I'm multiplying times 2x now to get 8, which would mean I need a plus 4. And then my check, does my plus 4 times my minus 3 equal negative 12? Yes, it does. And although this used to be down here in the denominator, I'm now going to write it up here on the top, 2x minus 3 times x plus 4. One last factoring problem, and then I'm ready to get to the division. I've got to factor x cubed minus 125. This problem is a cube problem, so I'm looking for my pattern of a difference of cubes. A cubed minus b cubed. I know the formula for that has the same sign for the first factor, and then I square the a. I have the product of the a and the b, and then I square the b. My signs start out with the same sign as the problem, then the opposite sign of the problem, and the last sign is always positive because it's a squared term. So if I want to factor x cubed minus 125, my first factor would be x minus 5 because the cubed root of x cubed is x and the cubed root of 125 is 5. For my second factor, I'm going to square the x to get x squared. I'm going to multiply 5 times x to get 5x, and I need to make that the opposite sign. And for my last term, I'm going to square the 5 to get positive 25, and that last term is always positive. So down here, I have x minus 5 times x squared plus 5x plus 25. Now I'm finally ready to reduce. Any factor from the top that is common with a factor from the bottom can be reduced. So I have an x plus 3 on the top and the bottom. It's okay that they're in the same fraction. I also have an x plus 4 on the top and bottom that can be reduced. Nothing else is in common. So for my final answer, I have x plus 3 times 2x minus 3 over x minus 5 times x squared plus 5x plus 25. And that's my answer to question 14. So I'm going to wrap up this video here, and then we will have additional videos for the rest of the sample review for the third quarter test. So thanks, and move on to the next video if you need some more answers.